Okay, YouTube, in the last few videos we've been exploring reference angles. In this video what we're going to do is we're going to kind of explore how we could use reference angles to evaluate trig functions of some angles theta. And so what I want to kind of start with is this idea that what if, for instance, we were to have a couple of angles, and what we are told is that the point 3 comma 4 is on the terminal side of this angle, but the point negative 3 comma positive 4 is on the terminal side of this angle. What I would start by doing is going to the right 3 and up 4, and I'd say, okay, well, here's my angle in standard position. This is the point 3 comma 4. And the thing here is this: when we look at this, I suppose we would say that here is our angle theta on the inside. That angle theta right there actually happens to be equal to its reference angle, also theta prime. Let's go ahead and take a look at negative 3, positive 4. And as you might suspect, it really kind of creates the same situation, but with an angle that terminates in the second quadrant. So what I mean by the same situation or similar situation is this. Here's our angle theta, but when we drop down this altitude, what I want you to see in either situation is that we know the y value is 4. Here it's 4. Here we know the x value is 3. Here we have negative 3. And so the only difference between these two triangles happens to be that here our x value is negative and here our x value is positive. Otherwise they're in essence the same triangles. So what is it that is similar about them that causes this to happen? And it's the fact that the same triangle is formed, or that they have the same reference angles. So we'd say that two angles that have the same reference angle, we could put it this way. Two angles that have the same reference angle, their sine values or cosine values or tangent values at those angles will have to be the exact same numbers, but might be different in SIG and sine. So what we're saying here is that the values of the trig functions for a given angle theta, so we've given a theta here, we say are exactly the same as the values of the trig functions for the reference angle theta prime, except possibly for the sine. So that is to say, if somebody asks me to go find the sine of pi over 4, the sine of, let's do it this way, let's do the sine of 30, we'll keep it simple. The sine of 30 degrees, I know that 30 degrees lies over here, here's my 30-degree angle, and that the sine of 30 degrees is equal to a half. If I were to also do the sine of 150 degrees, which by the way, I know that 150 degrees happens to stop 30 degrees shy of the x-axis. So here's my 150-degree angle right there. I would say that this also has to be a positive a half, but because these form the same triangle, and when we do our y value divided by our hypotenuse, in either case, we're always going to get the same numerical value there. If I now had done something like sine of 210 degrees, 210 degrees would be 30 degrees past 180, so here's our 210-degree angle. This leftover is 30 degrees, but what I want you to see again is that it's the same comparison, except for this time we would have a negative 1 here over a positive 2 to get back to the origin. And then likewise with a sine of 330 degrees, which is 30 degrees shy, there's your 330, but it's 30 degrees shy of the x-axis again. So the sine of 330, it has to be the same as all of these numbers here, except for this time it is negative, because sine terminating in the fourth quadrant is negative. So basically what we're going to be doing is this. If anybody wants us to go find a trig function of any angle, like these three angles down here, what we're going to do is we're just going to go find the trig function value of its reference angle instead. So the value of a trig function for any angle of theta is found as follows. Step 1, find the associated reference angle, theta prime, and then the function value for theta prime. Because the function value for theta prime has to be the same thing as the function value of just theta, but might be positive or negative depending upon where it terminates. Now for the second step, it says use the quadrant in which theta lies to prefix the appropriate sign to the function value in step 1. So what I want to do here is I want to kind of put these steps to use and kind of see what these look like. So we'll start with our sine of 300 degrees here. Now, here's what I want to start with. Instead of doing the sine of 300 degrees, what we're going to do is we're going to do the sine of theta prime. So for a 300-degree angle, recall that 300 degrees, that would be like get to the 270 and then go 30 past. So if we've gone 30 past the 270, then that would mean that this inner part here is a 60. So the benefit to reference angles is saying that instead of having to do the sine, cosine, or tangent of the original angle, we can always just use the reference angle instead. And the fact of the matter is the sine of 60 degrees is one of these exact values that we will want to have memorized. So let's recall that the sine of 60 degrees, if we did sine of 30, 45, and 60, remember those are all over 2, and then on the tops they go root 1 over 2, root 2 over 2, root 3 over 2. So our sine of 60 is root 3 over 2. So we'll go back and put this in. So now we would say root 3 over 2. Now, as far as step 2 goes, it says use the quadrant in which theta lies to prefix the appropriate sign to the function value in step 1. So I guess what we're saying is this. This sign value right here, remember all students take calculus. Because our angle terminates in the fourth quadrant, the only thing that's positive there is the value of cosine. So for the second step, what they want us to do is they want us to go out in front here and put in a negative value in front of our trig function, because we know that if we're going to find the sine of 300, of course it has the same numerical value as the sine of its reference angle, which is 60, but also that it would be negative because it terminated in the fourth quadrant. So let's take a look at the tangent of 5 pi fourths. How about we start with this? We're going to rewrite this in terms of its reference angle. So 5 pi fourths, let's remember this is pi, this is 2 pi. So this would be like 4 pi fourths here. This would be like 8 pi fourths over here. So 5 pi fourths would be a pi fourth, or a 45-degree rotation past 4 pi fourths. So here's our 5 pi fourths. So here's what we want to do here. First of all, find the reference angle, which in this case happens to be just a pi fourth radian measurement. And then what we're going to do is we're going to evaluate for tangent of pi fourths. Now the tangent of pi fourths, or the tangent of a 45, of course, is this pretty consistent, 1. So what we're going to get here is 1. So now for step 2, let's go back and say, now should this be a positive or a negative? Given that, we have this mnemonic here, all students, students take calculus, we see that because our angle terminates in the third quadrant that our value of tangent should indeed be positive. So what we're saying here is the tangent of 5 pi fourths has to be the same as positive 1, because it's the same as the tangent of its reference angle, and tangent's positive in the third quadrant. So for our secant here, now the interesting thing about secant is this. We are going to find cosine first. So what this means for us is we're going to go find the cosine of negative pi sixth. So sketching a negative pi 6. A pi 6 is a 30-degree rotation, and we're going in a negative direction here, so clockwise. So here's our angle, negative pi sixth. So let's start with its reference angle. Its reference angle would just be the positive of this angle. Remember, reference angles are always acute and they're always positive, but we'd say between the terminal side and the x-axis. So we're going to say that what we want to do is get the cosine of pi 6 instead. And so what we'll end up doing is saying that the cosine of negative pi 6 is equal to the cosine of pi 6, but now we want to evaluate this. So the cosine of pi 6, which is a cosine of 30, we know that the cosine of 30 would have to be the same as the sine of 60, and our sine of 60 is this root 3 over 2. So let's go ahead and say that this would be a root 3 over 2. So now the only thing we haven't done is assessed whether or not this should be positive or negative. So using our mnemonic device here to remember this, all students take calculus, we know that cosine is the only positive function down in the fourth quadrant, and that our terminal side lies in the fourth quadrant. So this cosine is positive, and this is positive here. So we would say that this is the value of the cosine of negative pi 6. So using what we know about reciprocals, we know that the secant of negative pi 6 is equal to 1 over the cosine of negative pi 6. So what we're going to do now is we're just going to use the reciprocal of what we had here. And so we'd say then the secant of negative pi 6 is really truly equal to the reciprocal of positive root 3 over 2, which is 2 over root 3. Or another way of writing this would be 2 root 3 over 3. So as we kind of explore these a little bit further here, we're going to look at some where the angles actually happen to be well over full rotations, or full 2 pi rotations. So for something like cosine of 17 pi 16ths, the first thing I would suggest doing is let's find a coterminal angle to 17 pi 16ths. So what we're going to do is we'll take our 17 pi 16ths, which is many rotations, we're going to subtract off 2 pi. Now 2 pi, 6 pi, let's see, 2 pi, that would be 12 pi 6 there. When we subtract off 2 pi has a common denominator with 17 pi 6 of 6. So 17 pi 6 minus 12 pi 6, what we're going to say is that this has to be the same thing as the cosine of 5 pi 6, because 5 pi 6 lands in the same place as 17 pi 6. So let's go ahead and sketch out our diagram here. Remember that this is over here pi, so 6 pi 6. So it seems to me that we're going to go 5/6 of that pi rotation. So we say 5 pi 6. But this would mean also that our reference angle here is pi 6. So what we're going to do instead of finding cosine of 5 pi 6 is we're going to find cosine of pi 6 instead. Now one thing that's worth mentioning is that the cosine of pi 6, suppose cosine of pi 6 here, cosine of pi 6 or cosine of 30 is root 3 over 2. So let's go ahead and install this here. We would say root 3 over 2. Whoops. We'd say this is root 3 over 2. But one thing worth mentioning is that we need to go back and check the sign. So now we know that this angle terminates in the second quadrant. So for all students take calculus, we know that sine is the only thing positive here, and we were exploring a cosine. So that must mean that this is negative root 3 over 2. And this should have a negative out in front as well. So this negative 3 over root 2, that's what this negative root 3 over 2, that's what our original trig function value equals. So let's take a look at our sine of negative 22 pi thirds. So negative 22 pi thirds, I'd much rather deal with positive angles. So what I'm going to do is I'm going to add on 2 pi here. Or in other words, we're going to say negative 22 pi thirds plus 6 pi thirds. So we would have negative, suppose this would be 16 pi thirds. Let's add on another 2 pi thirds. Sorry, 6 pi thirds, which is 2 pi. So again, negative 10 pi thirds. We'll add on another 6 pi thirds, or another 2 pi. We get negative 4 pi thirds. If we do this one more time, add on a 6 pi thirds. What we end up with then is 2 pi thirds. And so what we should know is that 2 pi thirds is coterminal with this angle. So I know that if I find the sine of it and I find the sine of 2 pi thirds, it would have to be the same thing anyways because they land in the same spots. So for 2 pi thirds, let's go ahead and sketch our 2 pi thirds. That would be two 60-degree rotations here. So we say here's our 2 pi thirds here. Now knowing that this is 3 pi thirds, that would tell us that this leftover angle here is this leftover pi thirds reference angle. So to find the sine of 2 pi thirds, what we'll do instead is just find the sine of its reference angle since it's the same anyways. And all students take calculus. Knowing that we are finding sine and it terminates in the second quadrant, we should know that this is a positive angle right here, or positive value. So sine of pi thirds or sine of 60, let's remember that sine of 60 here, the sine of 60 is root 3 over 2. So we'll go ahead and put this in here. We say positive root 3 over 2. So the idea will be this. If you ever want to evaluate a trig function, find the reference angle first, and then let's go find the sine, cosine, or tangent of that reference angle and affix the proper sign. Cheers.